All right, let's jump right into this explainer. Today, we're going to uncover the invisible architecture that literally makes our modern, connected lives possible. Think about it. Every single time you send a text, stream a movie, or just quickly check your email, you are relying on an unbelievably complex web of connections. We are going to demystify exactly how these networks, specifically LANs and WANs, actually work behind the scenes to keep our entire digital world spinning.
Here's a quick roadmap of what we're covering. Connecting our digital world, the local area network, the hardware powering your LAN, the wide area network, and finally, connecting it all together.
Section 1. Connecting our digital world. So, have you ever actually stopped to think about what is physically happening when you tap a button on your phone and, almost like magic, a document spits out of a printer across the room? Or how your smartwatch instantly syncs your heart rate right to your health app? I mean, it feels like magic, right? But it's actually a highly orchestrated system of digital communication. It's all thanks to a network. And at its core, a network is literally just two or more devices shaking hands and sharing data. Whether it's happening through invisible radio waves like Wi-Fi and Bluetooth, or through good old-fashioned physical cables, a network's entire purpose is just to let computing devices talk, share resources, and pass raw data back and forth. Now, starting at the absolute smallest scale, we have what's called a personal area network, or PAN. If you've got a smartphone controlling a robot vacuum, or if you're wearing wireless earbuds right now, you're using a PAN. These devices operate in extremely close proximity. We're usually talking under 10 meters here. Basically, if it requires physical closeness to work, you are utilizing a personal area network.
Section 2. The local area network. Well, what happens when we expand beyond just a few meters? That's when you get a LAN, or local area network. This is the network that connects an entire building or campus together. Think about your school computer lab, your office building, or honestly, even the smart devices scattered all throughout your own house. A LAN allows all the users in that specific location to pool their resources. So instead of a company buying 50 separate printers for 50 employees, they just share one, along with shared software licenses and one single internet connection.
The real defining characteristic of a LAN, though, is its strict geographic limit, and, crucially, who owns it. A LAN is confined to a single site, and all the hardware making it work, from the routers to the cables hidden inside the walls, is entirely owned by the site owner. If your school or company bought the equipment and it stays inside their building, you are absolutely looking at a local area network.
Section 3. Hardware powering your LAN.
So, what are the actual physical boxes with all the blinking lights that make a LAN function? Well, every LAN relies on specialized hardware working as a team. First up, you have servers. These are basically the heavy-lifting brains of the operation, super powerful computers that store all our files and run vital security applications like firewalls. Then you've got wireless access points, or WAPs, which beam out the Wi-Fi signal so you can roam around with your laptop without tripping over Ethernet cables. And finally, you have switches. You can kind of think of the switch as the local traffic cop for your digital neighborhood. You see, every single device on your network has this unique hardware footprint known as a MAC address. When you want to send a file to the server, the data hits the switch. Boom. The switch instantly reads that specific MAC address and forwards the data strictly to the intended device. This ensures all that local data traffic flows incredibly fast without crashing into itself. Section 4. The wide area network.
All right, local traffic is great, but what happens when we zoom out to the macro level? Like, what if a LAN in New York needs to talk to a LAN in London? That's where the WAN, or wide area network, comes in. When businesses have multiple offices spread across different countries, they have to connect their individual LANs together into one massive WAN. And actually, the absolute largest, most complex example of a wide area network is something you're literally using right now, the internet itself. You can spot a WAN pretty much immediately because of two main things: scale and ownership. Unlike a LAN, a WAN spans multiple geographic sites. We're talking across cities, countries, or even continents. And because of this massive continent-spanning distance, an individual company obviously can't just lay their own private cables across the bottom of the Atlantic Ocean. Instead, WANs have to rent space on massive utility infrastructures and telecommunication companies to lay the groundwork and provide the leased lines to bridge those giant gaps. Let's test this logic in the real world for a second. If an international company links offices in Dhaka, London, and New York, spanning thousands of miles and requiring external utility infrastructure, that is unmistakably a WAN. Conversely, if all the devices are just sharing a single connection inside one high school building, that's a classic LAN.
Section 5, connecting it all together.
Now, despite how much we throw around the word wireless, the vast majority of our digital world actually relies on physical cables. Networks basically use two main physical highways to move data around. Copper cables transmit data using pulses of electricity. They're the cheap, flexible, everyday workhorses. Fiber-optic cables, on the other hand, are literally hair-thin tubes of glass firing pulses of light at speeds that are almost impossible to imagine.
And your choice between these two cables is basically what dictates whether you're building a LAN or a WAN. Because electrical signals tend to run out of steam over long distances, copper is perfect for the short hops inside your local LAN, like wiring up that school computer lab. But for a WAN connecting entire cities, you absolutely have to use fiber optic cables. Light doesn't suffer from electrical interference, which gives you massive bandwidth over global distances. Fiber is for sure the true physical backbone of the internet.
So, our entire digital world really relies on this beautifully nested ecosystem. You've got the PAN connecting your smartwatch, which talks to the LAN in your home, which is then routed out through massive fiber optic cables to the global WAN we call the internet. So I'll leave you with this as you look around your room right now. Just how many invisible networks do you think are transmitting your data at this exact second?